Today we're taking a look at solving systems of equations by graphing. So in order to do this, it says use the graph to determine if there was a solution and show algebraically if it is a solution. So for letter A here, the solution for any system of equations is always a singular point, specifically where the two equations intersect. So the possible solution for this is -8, +5. We need to check with these two equations that -8, 5 is actually the solution to the system. So what we're going to do is we're going to put 5 in for y, and then we're going to put in -8 in for x. So 5 equals 5/8 times -8 plus 8. In order to figure out if this is a solution, this has to make a true statement. So we need to do some simplifying here. 5 is equal to 5/8 times -8. Okay, so technically this is 8 in the numerator. There's an 8 in the denominator right here, so this 8 is going to cancel with this 8, and we would just be left with -5 because there's a negative sign and a 5. And that's going to be plus 8, right? And then, or sorry, this is not 5, this is 3. I don't know what I was doing. It's -8, 3. And then 3 is equal to, we have -5 plus 8, which gives us 3. So we're good. We need to check it with the second equation as well. So we're going to plug in 3 is equal to -1/8 times -8 plus 2. That's going to give us 3 is equal to 8 and 8 would cancel. The negatives also cancel, so it would be 1 plus 2. And that is going to be 3 is equal to 3, so that also works. So this right here, -8, 3, is a solution. So this is how you would check algebraically if the point on the graph is a solution. So let's take a look at B. Letter B, our possible solution is right here. This point is 4, 2, right? So then we check the solution. We need to plug 4 in for x, 2 in for y. So we go 5 times 4 plus 2 times 2 equals 28. So this is going to give us 5 times 4 is 20, 2 times 2 is 4, equals to 28. So this is 24 is equal to 28. So right away we can say that this is not a solution. Okay, and that's because this is not a true statement. It has to make a true statement for both equations in order for that point to be a solution. Okay, letter C. As you can see here, we have two lines. These lines are actually parallel to each other. By the graph you can see that, but also by the slope you can see that. When the slopes are parallel, that tells us that they're not going to intersect. So parallel lines do not intersect. When the lines aren't going to intersect, what kind of solution is this? This is called a no solution equation, or a no solution problem, right? There is no solution that we get from this. Taking a look at the next part, it says, what if you are left without a graph? So how are we going to do this? So it says, determine whether the given point is a solution to the provided system. Is 0, -4 a solution? All we do is we plug in 0 for x, -4 for y. So -4 is equal to 0 minus 4, which that equals -4 equals -4. So the first one's good. For the second one, you're going to plug in -4 for y, -1/2 times 0 for x. So that's going to give us -4 is equal to 0 minus 1. Well, -4 is not equal to -1. So this one doesn't work. So this is not a solution. For this one right next to it, we have 5, -5. Is 5, -5 a solution? So we plug -5 in for y. 3/5 times +5 minus 8. And now we do some simplifying. So -5 is equal to, here we have a 5 in a numerator technically, because this would be 5 over 1. So those 5's cancel, and you just are left with 3 minus 8. which negative 5, 3 minus 8 is also negative 5, so that one's good. The second equation, we go negative 5 is equal to negative 2 times positive 5 plus 5. So that's negative 5 is equal to negative 10 plus 5. So that's negative 5 is equal to negative 5. So that one also works. So is 5, negative 5 a solution? Yes. Okay. So let's use your graphing skills to build the graph for the following system. Okay, so it says graph the blue equation on the graph to the right. Well, we know the y-intercept is 1, so we plot that first, 1. We know the slope is negative 1, so we go down 1 to the right 1, down 1 to the right 1. It's super important to be extremely precise when graphing these, okay? So we need to make sure that we're right following the slope perfectly here. I need to redraw my dots. There's one point. There's another point. Okay. Draw these in. There it goes. Now it's snapping. Draw it the other way as well. Super important to draw both directions. And then we're going to graph the green line. Okay, so the green line here is negative 8 is the y-intercept, so negative 8 is down here. And then it says to go up 1 to the right 2, up 1 to the right 2. So there's our line. Can graph that now. And what should happen is we should meet at an intersection point. And as you can see, our intersection point is right here. And that point is 6, negative 5. All right? So the point that they share is 6, negative 5. That says step 3. Step 4 says verify algebraically the point found is in fact a solution to the system. So we need to plug negative 5 for y. Negative 5 is equal to negative 6 plus 1. So that's going to be negative 5 is equal to negative 5. So the first one's good. I'm going to change that to blue because that was the blue graph. And then let's check the green graph. So that's going to be negative 5 is equal to 1/2 times 6 minus 8. So that's negative 5 is equal to 3 minus 8. So that's negative 5 is equal to negative 5. So that's also good. So both graphs work out to be true statements. So that means 6, negative 5 is in fact a solution. All right. Last question here. So it says graph the following systems of equations. In order to even graph these, it's probably easiest to put them in slope-intercept form. So that's where we're going to start. Okay. In order to get something into slope-intercept form, you have to isolate y. So this is plus 2x. So in order to get that off of there, we're going to subtract 2x from both sides. That's going to give us negative 3y, because these two x's cancel, is equal to, and then for slope-intercept form, your x needs to come first. So negative 2x, and then this is positive 21, so plus 21. Last step here to isolate y, because it's multiplication, you have to divide negative 3 from everything. That cancels the negative 3, so y is equal to 2/3 x minus 7. 21 divided by negative 3 is negative 7. The negatives cancel in there, so it would just be 2/3. Let's graph it. So negative 7, negative 7, and then up 2 to the right 3. Puts us right here. Graph that line. Should look something like this. Graph it in the other direction. Should look something like that. All right, let's do the next one. So the next one, I like to add y to the other side first. So that's going to give us these y's cancel, and we get 2x equals 3 plus y. We need to isolate the y, though, so I'm going to subtract the 3 to the other side. That gives us 2x minus 3 is equal to y. So we go negative 3. We go up 2 to the right 1. And then we just graph in this line right here. I don't like how that graphed. So our point is at negative 3, which is right here. Up 2 to the right, or up 2 to the right 1 puts us here. graph this line like this. Like that. And as you can see, they intersect at a point once again, right here. That point is going to be, looks like -3, -9. Yep. So -3, -9. Now we have to check our answers, okay? So -9 is our y. I'll check the blue one first. So -9 is the y. 2/3 times -3 minus 7. Okay, so we should get -9. So -9 equals 3 and 3 cancel. -2 minus 7 is in fact -9, so we're good there. On the other side of things, we have 2 times -3 minus 3 is supposed to be equal to -9, so that's -6 minus 3 equals -9, which that also is true. Okay, so now we can circle our answer. -3, -9 is in fact a solution. Okay, and that's how you do graphing systems of equations to find a solution. All right, if you have any questions, feel free to message me on Canvas. I would love to help out. Hope you have a great day.